Chapter 21, New Renewable Energy Sources. So today we only obtain just under 2% of our global energy from renewable energy sources, whereas fossil fuels are still providing 81% of the world's energy. Over the past 4 decades, solar, wind, and geothermal energy sources have grown far faster than the overall energy supply. As we look at this graph on the top right, we can see a world's energy supply pie chart, and you can see that oil, coal, and natural gas are still dominating the world energy supply. And as we look at the bottom, we can see that the US consumption of renewable energy is 11.5%, and we produce 17.7%, which is a step in the right direction. New renewable energy provides the ability to generate electricity, the ability to heat air or water, and the ability to fuel vehicles. The design, installation, maintenance, and management required for renewable energy provides a major source of employment today, which is known as green-collar jobs. Already 11 million people work in renewable energy jobs around the world. And renewable energy alternatives provide us with an economy that is diversified, as well as reduce the prices of renewable energy tremendously, and allows us not to be as reliant on imported fuels. It also helps people in developing countries ways to produce their own energy. Lastly, shifting to renewable energy also alleviates the life cycle of greenhouse gases. Electricity from wind power and solar power is cheaper than electricity from fossil fuels and nuclear fuels across large portions of the United States. As of 2019, nearly all the world's nations and 31 US states have set official targets for renewable energy. So as we can look at this graph on the left, we can see that most of the Midwest uses wind power and utility scale of solar power. And fossil fuels and nuclear power have received more tax breaks than renewable energy sources. And research concludes that across the world today, for every $1 in taxpayer money that goes towards renewable energy, 2 to 4 goes to fossil fuels, which really doesn't help our transition from fossil fuels to renewable energy. Solar energy, in simple terms, is energy that is from the sun. As you can see through the diagram, the energy obviously gets absorbed by the solar panel, thus creating electricity. And some benefits to this include that it doesn't produce any air pollutants or carbon dioxide, as well as have minimal effects on the environment. Some limitations include the lack of consistency when it comes to sunlight. Amount of sunlight varies depending on the location, time of day, and season of the year, and weather conditions. The amount of sunlight that reaches the surface is quite small. However, a typical home has enough roof area to meet all its power needs with rooftop panels that harness solar energy, thus allowing us to move from commercialized electricity. We can collect solar energy through passive or active methods. Passive is an approach where buildings are designed to maximize sunlight absorption in the winter, yet minimize it in the summer. It requires no equipment other than buildings with many windows. Active is an approach where technological devices are used to focus, move, or store solar energy, thus solar panels. At much larger scales, power can be available at homes and businesses via the electrical grid. CSP is a way of generating electricity at a large scale by focusing sunlight from a large area onto a smaller area. CSP holds promise for producing tremendous amounts of energy. However, one big downside is the environmental impacts. All the land beneath the mirrors is cleared and graded and destroying sensitive habitats for desert species. And the maintenance requires a tremendous amount of water, which is scarce and precious in these desert regions. Wind power is electricity generated by the wind by using wind turbines, which are mechanical assembles that convert wind's kinetic energy into electrical energy. Some type of wind energy include utility scale, which is designed to be used by utility companies, offshore wind energy, which is used and planted in waters off the coastal areas, and small scale wind energy, which is smaller in size and used to meet energy demands for a local area. Turbines are often created in groups, and such development is called wind farms. Wind currently provides just a small proportion of the world's power needs. However, it is growing fast. Denmark leads the world in obtaining the highest percentage of its energy from wind power. In this small European nation, wind farms supply nearly half of Danish electricity needs. Experts say that wind's power growth will continue only because a small portion of this research is currently being used, and the price of wind powers are actually lower than the cost of fossil fuels. However, in the United States, wind power growth has been quite difficult because Congress has yet to commit to a long-term federal tax credit for wind developers. But instead, they just pass a series of short-term renewals, thus leaving the industry uncertain of where and how to invest their finances. Geothermal energy is thermal energy that arises from beneath the Earth's surface. It can be harnessed directly from the surface. However, most times it is through wells, which must be drilled hundreds or thousands of meters towards heated groundwater. As you can see throughout this diagram, you see the magma heats the groundwater, thus creating steam, therefore creating electricity. Most energy sources use wave energy, which is a type of energy that is harnessed through the motion of the current. EGS is a recently developed approach where engineers drill deeply into a rock, fracture it, pump water into it, then retrieve it when it reaches a certain temperature. Another ocean energy is tidal energy, which is energy harnessed by erecting a dam across the outlet of a tidal basin. Water flowing with an incoming and outgoing tide through the dam turns the turbines, which then creates electricity, as you can see from the diagram on the bottom right. Lastly, energy storage, which is the capture and accumulation of energy for use at a later time. Storing energy is most familiar to us through the term battery, which is a device that employs chemical reaction to generate electricity. It has been challenging to store electricity easily and cheaply in large quantities for use when and where it is needed. That is why most vehicles rely on gasoline than electricity. However, there have been a huge amount of improvements so that large-scale storage will be necessary to convert our electric grids to accommodate rising amounts of solar and wind power. This can be seen between the transition between gas and electric cars, mainly through Tesla and other, obviously, hybrid vehicles. And that is all, and thank you for listening to my presentation.